So this is the volume of a cylinder. V is equal to pi r squared h. The formula for the volume of a cone is V is equal to pi r squared h over 3. Now, do these two formulas kind of match up with what we saw in that video just now?
Yeah.
Absolutely, right? We saw that 3 cones filled up one cylinder with the same height and the same radius. That's important, right? They have the same height and the same radius. So 3 cones filled up one cylinder. So the volume of one of those cones is going to be 1/3 or over 3 the volume of a cylinder that's the same size. Yeah. Go ahead, yeah. So a lot of times it's really hard for us to remember 3 different formulas. If we can remember that 3 cones make one cylinder, we only have to remember the formula for a cylinder. Because when it comes to cones, we can just divide it by 3. Does that make a little sense? Hopefully. Finally, we have the volume of a sphere, which we talked all about yesterday. V is equal to 4 pi r squared h over, oh, I'm sorry, I messed that up. I was thinking about cylinders here. 4 pi r cubed over 3. That's our formula for a sphere. Now we could go into explaining the relationship with the sphere and cone, right? Because we saw that a cone plus a sphere equals a cylinder. So this formula plus this formula actually does come out to pi r squared h. We could break that down, but it's a little bit more advanced than we really need to understand. But it will work out. I tried it this morning. If you add these two formulas together and break it all down, you do end up with this orange formula here. So the cylinder's volume, let's just write a note here. 3 cone volumes equals 1 cylinder volume. We also saw that 1 cone volume plus 1 sphere volume equals 1 cylinder volume as well. So I want to ask you this. We have these two kind of word equations here. 3 cone volumes equals 1 cylinder volume, and 1 cone volume plus 1 sphere volume equals 1 cylinder volume as well. So what's the relationship between a cone and a sphere? How many cone volumes would fit into 1 sphere volume based on these relationships here? 2. How'd you get 2? Just thinking logically?
Because since if it's 3 cones and 1 cone and 1 sphere, then it must be 2 cones and a sphere.
Exactly. You're right. Let's break down exactly what Azalea just said. We can think of this kind of like a system of equations. 3, I'm going to say CO for cones, is equal to 1 CY for cylinders. 1 CO plus 1 SP for sphere is equal to 1 cylinder. I should probably make my ones look a little bit better. So if 3 cones is equal to 1 cylinder, and 1 cone plus 1 sphere is equal to 1 cylinder, then 3 cones is equal to 1 cone plus 1 sphere. Right? If both of these underlined expressions equal the same thing, we can set them equal to each other. Give me a thumbs up if you see what I did there. Good. Now if we wanted to solve this equation, we could subtract one cone from both sides. And we get 2 cone volumes equals 1 sphere volume, exactly like Azalea said. 2 cones would fill up 1 sphere. 3 cones would fill up 1 cylinder. So it's, at least I think it's a little bit interesting how all these are related to each other and kind of proportional in a way, like we've been talking about. You don't necessarily have to write this part down. We're just trying to visualize what's going on here. So let's get some steps written down here, because I think the steps yesterday helped a lot. We'll start with cylinder. The first step is identify R and H. What's my radius is always going to be the first question we ask when we're finding volume, no matter what the shape is. What is my radius? Once you have the radius, you're going to square the radius, R times R. Just like yesterday, the third step is you're going to multiply by 3.14. In step 4, instead of multiplying by 4, like we did with the spheres, now we're going to multiply by h, the height of our cylinder. I'll move this up a bit so you can see. So you figure out what radius is. Square that number, multiply it by 3.14, and then multiply that number by the height. Boom, that gives you your volume right away. 4 steps instead of 5, because we don't have to divide by 3 at the end. With a cone, we're still going to start by identifying R and H. Again, if we don't know what our radius is, how are we going to know what to plug into our equation? Same with the height. We're going to once again square our radius, R times R, and we're going to multiply that number by 3.14, or pi. You're going to multiply by h, which is our height. Before we get to step 5, what do we notice about these 2 sets of steps? They're exactly the same, right? Whether you have a cylinder or a cone, you find the volume the exact same way, except because one cone is 1/3 of one cylinder, our last step when finding the volume of a cone is divide by 3. We've got to find 1/3 the volume of a cylinder that's the same size. We already have the steps for a sphere on the previous page, hopefully in our notebooks, but I'm going to write them down here as well, just so we could see how similar these processes are. If we remember, our first step was identify R. No need to identify the height, because that's not part of our formula. Plus, the height of a sphere is just the diameter of a sphere, if you think about it. Step 2 is we're not going to square R, we're going to cube R. R times R times R. But then we're still going to multiply by 3.14. So step 3 is the same across the board. Steps 1 and 3 are exactly the same across the board. Now spheres, it's a little different. Instead of multiplying by h, we're going to multiply by 4. Then divide by 3. Let's draw some example shapes here. Where's my red pen? So there's some nice diagrams for us, just so we can remember where to find the radius, where to find the height in a cylinder and a cone, and then what that radius looks like in a sphere. All of our drawings, all of our diagrams, both on the worksheet today and the SBAC in 2 weeks from now, or I guess, yeah, technically 2 weeks from now. What was I saying? I don't know. All the diagrams, that's what I was saying. All these diagrams are going to look exactly like this. They might be rotated. Some of the cylinders might be flatter. Some of the cones might be wider. But overall, you're going to have a height and a radius, a height and a radius. And for spheres, you're just going to have a radius. Questions about any of these 3 volume processes? Good. Perfect. So we've got tons of time here to get this practice done. Now, even with cones and cylinders, we have to make sure that we're not plugging in the diameter. All 3 of these shapes have a circle in them. That's why we're using pi in all 3 of our formulas. But if you're given the diameter of a cone or the diameter of a cylinder, do not plug that number in. Make sure you cut it in half to find the radius first, and then plug it in. Anyone not get a worksheet? Perfect. So let's take a look. I'm going to take a look at number, let's go to the back side. Let's do number 8. Up here at the top, number 8. So in number 8, what's my radius here? 2, exactly. We see that the circle on the bottom is a full line with 4. So our radius has to be 4 over 2, which comes out to 2. Our formula here is V is equal to pi r squared times h. What's my h? 4, right? Do we need to cut that 4 in half? No, absolutely not. We always want to take the full height that's given to us. Boom, just like this. You're going to square 2, multiply it by 3.14, multiply that by 4, and divide that number by 3. You're essentially taking this formula and breaking it down step by step. Now, you don't have to write out every single step. I do at least want to see you plugging the radius and the height into this formula like this, because on the SBAC it's going to be using the formula as it's written and not the broken down steps like the way that we learned it. But then we could just put this in a calculator. See if you can see it. There we go. 2 squared gives us 4, so 4 times 3.14. Actually, let me 2 times 2 first. Then we multiply that by 3.14. What do we multiply this number by? What's my step number 4? Multiply by the height, right? What's my height here? 4. And then finally we have to divide by 3, giving us 16.7 what? 4? 5. Our third decimal is more than 5. It's a 6. So we got to round that 4 up to a 5. 16.75. But what are my units here? Kilometers. What? Cubed, not just kilometers. 16.75 cubic kilometers, or kilometers cubed. Both ways are fine. So that's really all the amount of work that I need to see. What's your radius? Plug whatever numbers you can in, and then just plug them in your calculator, and you're good to go. Sound good? Real quick, what's my radius in number 10, just to check?
4.
4, good. All right, you guys are good to go.